Well, as promised, I did say that we're going to do this graphically. Let's look at the last question and see what it gave us. The last question, if you remember, the answers were x equals to -4 and 2, with a non-permissible value here of x not being allowed to be -6, which results in a vertical asymptote, right? Okay, so how do we go about plotting this and graphing this to show our answer is -4 and 2? Well, first things first, there's two methods. This method one is the one that you're more commonly familiar with. Okay, this is the one that you used in Math 20-1. And you're probably saying, well, I don't remember it. Well, watch. Here's something that will remind you right away. Remember, make that a y1, make that a y2. Now you remember? Plot them both in your calculator and find you got it, the intersect. Yes, the intersect is the thing that's going to help us graph this and find the answers. Aha, now you remember. And it's actually quite cool and easy at that point. Now, okay, so how are we going to do this? Well, first things first, let's put it into our calculator and see what happens. Okay, got the calculator going here. So being that this is a rational function, I really like this numerator over denominator function. That nice little, oh man, isn't that pretty? Because all you got to do here is put the 16. On the bottom, you put your x plus 6, and there's your rational function. There's no brackets, there's no figuring things out, there's no divided sign, and this looks pretty much like the question itself, right? On the bottom here, you're going to put your 4 minus x, and then you're just going to graph it. There's your two functions, y1, y2, graph it. Boom. And look at that. Oh, interesting. Interesting. Don't forget you had a non-permissible value at 2, 3, 4, 5, 6, right? So there's your non-permissible value. There's your asymptote. And if we made these graphs a little bit bigger, right, you will see that those lines get close to that asymptote but don't touch. But the most important part here is the fact that look at that. Look at that. Look at that. It's at -4, and there's your other intersect at 2. Now, I know and you know that I know that that's -4 and 2. But what if they were very, very close to that? Okay? What if they said, and the question said, prove it? Okay? Show me a method and prove it. Well, of course you can prove it. All you got to do is go second and hit calc. Remember how to do this? Second, calc, intersect. Does that bring back some memories from Math 20-1? Oh, it brings back nightmares, man. Okay, sorry about the nightmares then. Bring that over close to that dot there, close to that one intersect, hit enter 3 times, and look at that. You got an answer of 2, 2. Now, I know it has a y value here, but I want to go back to this. Remember this guy? There's no y value in here. Look at our original answer was x's only. There was no y, right? So you make sure that when you tell me what the answer is graphically, you don't include a y value because there is no y value in the original function, right? So that's very, very important to remember. But why do we need the y value? Well, why you need the y value is because that's going to help us graph it. Ah, I see. Okay, so let's put the graph in there. Notice this first value was at 2, 2. So let's put that point in right now. There's my 2, 2 point right there. Put my asymptote in. -1, 2, 3, 4, 5. There's 6. Blah, 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 blah. There's my asymptote. Okay? Now, I know my other point is going to be at 4. So let's put that in right away. So let's find this on the calculator. Let's find what that thing is. Second calc. Find the intersect 5, mouse it on over, okay? And let's find that intersect because we're going to use that y value now, right, to help us graph. Y value is 8. Neat. Okay, so now we get a much, much more accurate graph. Look at that. That's where our line is going to go through. So let's put our line through here, okay? Our line goes like that. Now, if I don't extend my line like this all the way through to the edges of the graph, your line must have an arrow on it indicating that it's continuous. You have to have an arrow on both ends. If you extend that line all the way to the edge of the graph, you don't need an arrow. Okay, now, here's your other thing. Remember that this other graph, let's take a look and see what it looked like again, was a bendy graph. It's one of those bendy ones, but it does go through our intersect points. Okay, so let's just put that right through our intersect points. There it is, and there it is. There's our graph, a nice sketch. Our other part of the graph is right here. And again, I would put the arrow on this part. You don't need the arrows on the other part because you've extended past the graph anyways. Technically, you should have this right up to the edge like this one right up to the edge like that as well. Okay, boom. And then that's good. This one, oh boy, okay, little tough to put it to the edge because I'm right on the edge of my smartboard here, but there we go. Okay, those don't need arrows because of course they are right to the edge of your graph. But indicate your points here and here and indicate your answers as x equals to -4 and 2. That's really, really, really important. Remember, no y values. Okay, whew. That was supposed to be review from last year. Let's go on to the other method here. This is method 2. This is called single function method. Now, this is also really, really easy. Let me show you how it works. Just clear this off here. I'm just going to wipe this out because I don't want this to confuse us at all. Okay, easiest thing about this, take this whole function here and just bring it over to the other side. So think about what we have. We have 16 x plus 6, bringing the 4 and the x over, just changes the sign to -4 plus x, and look, lo and behold, look what it's equal to. It's equal to 0. And remember, that's actually where the y was. So y now equaling to 0, do you remember this from math 10? Y equals to 0 means that you are in fact finding the x-intercept, or in our case, the x-intercepts, right? So rewriting this and putting this into your calculator. Okay, well, let's go back to your calculator. Well, our calculator's a mess. Let's clean this up first. But here's the cool thing about this. You actually have a part of that function already written into your y equals 2. And that's your y1. That's the 16 over x plus 6. Now, all you got to do here is just mouse over. There we go. Put in the -4 plus x, which is the y2, but just the additive inverse of that. In other words, flipping the sign. Go down here to y2 because you don't need it anymore, and then graph this and watch this. Woo, baby! Look at that. Look what you have. There it is. There's your x-intercept at 2. There's your other x-intercept at -4. And if you think about it, if you were to let this graph go a little further, you will see at -6 is your non-permissible value. Cool. But do you remember how to find that value using your calc on your calculator? Yeah, remember, being that this is an x-intercept, it's known as a root as well. Or, guess what? Also known as a 0. That's right. So hit 2. There's your left bound, right bound stuff that we have to do. Do you remember that? Enter, move it over to the right bound, hit enter, and look at that. Lo and behold, it is x equals to 2. You could do it to the other side as well. Go second calc, find the 0, mouse it over to your left bound. Remember, you have to be on the left side of that intersect to make sure that you've got the right bound set up. There it is. And on the right side of that intersect, there we go. Hit enter again, and look at that. There's the -4. So how are we going to graph this now? Real simple. Go over here and put all the values that you know down already. You know the value at -6 is, of course, your asymptote. You know you have a value at -4, which is your x-intercept, your other x-intercept at 2. You know that this graph is going to come very, very close to here. It's going to bend down like this and kind of just shoot off in this direction looking like that. Put an arrow on that end since we didn't complete it. That's what it looks like. 2 methods of graphing. I think it's just delightful.